As promised, I have another problem with regards to Coulomb's law. And this time, unlike our previous example, we had one with a right triangle configuration. There were 3 point charges, but arranged in a right triangle. What if we change the configuration and we make it an equilateral triangle? What do we do and how do we solve it? Well, still the same principles, except that the probably the distances will change. That's why it's again, I go back to what I said in the first video. It is critical that you get the correct forces and you get the correct distances. Okay, so let's just go through the problem. It says 3 point charges are located at the corners of an equilateral triangle as in the figure. Find the magnitude and direction of the net electric force on the 7 microcoulomb charge. And we can see that the 7 microcoulomb charge is positioned at the top or at the tip of our equilateral triangle. The other two charges are valued at 2 microcoulomb and the other one at negative 4 microcoulomb. So our reference charge will be let me just get my pen, our 7 microcoulomb charge. And it just would be the same as our solution for the first problem. It's just that the distances again will be different. So we have to consider the distance. So this is already stated. So the effect of, okay, probably it's easier to give them some designations. We can say that this is Q1. Let's call this Q2. And let's call this Q3. So we'll be getting F21, F31. So eventually we have to get the net force on the 7 microcoulomb charge, which we identified at this point as Q1. Okay, the distance, I don't think we'll have problems with distances because it's an equilateral triangle, meaning all three sides are have the same length. So that's zero point 0.5 meters, another zero point 0.5 meters for um, 1 2 or 2 1, and zero point 0.5 meters also for 3 1, and also zero point 0.5 meters just in case you want to get to 3. So this is now our R 3 1, and this is our R 2 1. Okay, no need to convert because it's given in meters, so nothing no much conversions as compared to the other problem, because a while ago the distances for the first problem, by the way, was in centimeters. This one is straight out meters. So let's get first the forces. So let's have F31 since it's nearer on my end. So this is K Q3 Q1 all over R31 squared. Okay, F31 now is equal to 9 times 10 to the 9. Q3 is negative 4 times 10, negative 6. Q1 is 7 times 10, negative 6. That's why you have to be familiar also with your prefixes. R31, so that's 0.5 squared. So F31. This two I haven't really solved, so we'll be doing this from scratch. So that's 9. You can compute with me. I'm assuming that you have your calculators handy, so please compute as well so that should there be errors, you can let me know from message or probably a comment on the video. Okay, that's zero point 0.5 squared. So I'm getting 1.008 newtons. Okay, hopefully I'm getting it right because I haven't really solved this yet. So we will see in a bit. Okay, what about F 1. Okay, let's just, that will be 9 times 10 to the 9. 2 is 2 times 10 to the negative 6. And then, of course, our reference is 7 times 10, negative 6. And all over, the distance will just be the same, 0.5 squared. And my F21 is, I think it's, I'm gonna check. I think it's half, because this is, the other one is Q3 is 4, and this is 2. I'm not just so sure about that. So let's compute that. That's 9 to the 9 times 2, negative 6 times 7, negative 6. Okay, all over zero point 0.5 x squared. Okay, let me just get that. So I'm getting 0.504 there. Okay, the assumption was correct, because this is 2 and that's a 4. So this is 0.504 newtons. So we're good with that. We'll be using our, just get that, another sheet. We'll be using our vector addition. But let's first plot it. Again, if you will follow this method, you will be plotting here. Our Q1 is here. And what does it do? Let's see. Q1 and 3. So F31. So both of them, no, they're not both positive. One is positive, the other one is negative. So the tendency of our Q1 is to approach Q3. So it will go this way. Okay. So you can also do it here if you want to just check it out. See? Right there. You can see it from the figure. So we're doing it there. So now we can say that if this is 60, this is also 60. Okay, so this is now 60 degrees. I just wanted for you to see it on the figure so that you'll be able to get the angles correctly. So this is now F31. What about the relationship of 2 and 1? So both of them are positive, so it will go away. So it's going to go the other way. So it's going to be going here. So this is now my F21. So this is also 60 degrees. So you already have what you need to be able to solve the resultant force. So let's again do our usual. So this is F21 and F31. Let's not be so detailed about it. So this is X, Y. So my F21, by the way, is, let's just write them here, 0.504 newtons. And my F31 is 1.008 newtons. So this is now 0.504 cosine 60. And this is 0.504 sine 60. This is 1.008 cosine. So that's 270 plus 30, that's 300. And this is 1.008. I think that was a little too much zeros there. 008 sine 300. Okay, let's solve those. We'll see. That's 0.504 cosine 60. That's equal to 0.252. I'm assuming both of these are positive. Looking at the figure, 0.504 times sine, sorry for that, sine 60. That's equal to 0.436. And then 1.008 cosine 30. This is equal to 0.873. Let me just do that again. Okay. And 1.008 sine 300. Okay, I think I missed that. I think I inputted. So this is negative 0.873. I think, let me just do this again. 1.008 cosine 300. I think I inserted, okay, it's 0.504. I think I made an error there. Instead of 300, I pressed 30. So this is 0.504. Let me just check my values again so as not to have any error. 504 cosine 60, that's 252. Okay, 1.008 cosine 300. This is what happens when you're live. That's 0.504. 0.504 sine 60. That will be 0.436. And 1.008 sine 300 is negative 0.873. Okay, so what do we do next? Same banana. We need to get the summation. Okay, so we're getting 0.252 plus 0.504. That is equal to 0.756, and 0.873 minus 0.436, that is 0.437. Okay, and to get F1 is equal to 0.756 squared plus negative 0.437 squared, and get the square root of that. We're getting plus 756 squared, square root of your answer. We're getting 0.87. Okay, that will be the magnitude. Okay, if you can be consistent, let me just do that again. 873 Newton. So that we're using at least three significant figures. And we're almost done. Again, theta. Theta is tangent negative 1 Fy over Fx. That's negative, okay, sorry. Tangent negative 1 negative 0.437 all over 0.756. Our theta now is equal to, let's just get that finally. Okay, let me just get my shift. Negative 0.437 all over 0.756. Let's close that. We're getting 30.02. So that's negative 30.02, meaning it is below the x-axis. Okay, so that's how you solve another problem with 3-point charges, but the configuration is on an equilateral triangle. So hopefully the two problems will be enough to strengthen your skills in solving Coulomb's law problems. Okay, again, this is the problem. We had a configuration on an equilateral triangle, and what we did was, of course, take the forces individually and then get the vector sum. But again, critical would be to get the correct distances between the point charges, and then after that, that will just be a breeze. All you have to do is apply the formula. Okay, for questions or comments, you can comment in on the video, or you can send me a message. Okay, for now, that will be it, and good luck on your exams tomorrow. Thank you.